So we have defined the Poincare map last time. It was the map connecting the point on the y-axis on the positive side to the point on the negative y-axis by following the orbit. And we argued that the point is in the periodic orbit, then it must be analogous to the fixed point of the Poincare map. In this case, it's exactly symmetric point. So the map, it maps y naught to the minus y naught. That's characterizing the periodic orbit. Let's recall the previous lemma, previous class, about the big W. Big W was the distance from the origin, and the derivative of that big W has this simple form, minus 2 times x times f of x. So let's define this delta of y naught to be the difference of this big W value along the orbit from when the orbit moves from point y naught to its Poincare, the corresponding point after the Poincare map. So maybe from this picture, if the starting point is 0, comma y naught, then this ending point will be 0, comma p of y naught. And we want to evaluate the difference in the value of w. And since the w time derivative is given by minus 2 times x times f, we can calculate this as the anti-integral of the following type, where this capital T is the time it takes from traveling from this y0 to p of y0. Let starting point y naught is between 0 and alpha. Remember, the alpha is where the function f remains negative if the argument is less than alpha. Let me show the graph. This was the graph of f. So f was negative from 0 to alpha. Then initially the value of f, when it just starts from this point, the value of f will be negative because value of f will be negative when the argument is near 0. Since the value of f is negative, this integral will be negative, meaning that the value of w will decrease, which means the distance, the orbit, the distance of the points from the origin is decreasing. Therefore, by the time the orbit crosses the x-axis, the x-intercept, the coordinate of the x-axis will also be smaller than alpha, which means throughout the whole orbit, the x-coordinate will be between 0 and alpha, which means w has to decrease for the whole orbit from 0 to capital T. Therefore, delta of y0 must be positive. Must be positive because f is negative. So there's another negative sign here. So delta of y0 must be positive whenever y0 is between 0 and alpha. Let me again draw the graph of f in this xy plane. And let's draw the line where x equal alpha. So this dotted line is where x equal alpha. Let's consider a single orbit starting from some point and like this. So starting from y0 here, it goes to p of y0. If y0 is large enough, then it must hit this line of x equal alpha, because we already proved that any point starting from the green graph, if you go back in time, then it will hit the y-axis as some y0, which means y0 is large enough. It will hit also x equal alpha. Similarly to the bottom side. it will intersect also x equal alpha at the negative, the bottom half plane. Since we showed that any trajectory starting from the right half plane below the graph will hit the y-axis at p of y naught in this case, it means that if we decrease this point, then this hitting point will also decrease. If you increase this point, this y naught will also increase. Which means if y naught, if you keep increasing y naught, every value will go according to the arrow. So by making y naught large enough, you can make either this both intersection with the x, the height of this both intersection with x equal alpha, and p of y naught, everything, the absolute value of p of y naught, everything will grow indefinitely. It's important that as you increase y naught, you can make all these points going to infinity as large as you want. Let's define the time. Again, time at 0 is at y naught. And let's define the time that intersect first with the x equal alpha line to be time t1. This time will be t2, and this time will be capital T as we already defined before. And we will separately measure the difference of w value, so delta between this 2 times t equals 0 to t1 to be delta 1, and the difference of w between t1 to t2 to be delta 2, and difference between t2 to capital T to be delta 3. So let's write separately those deltas. First, delta 1 is the integration of, again, the same thing, x of t times f of x of t from 0 to t1. And here we will use this Lyapunov equation to change the integration variable. So remember, x dot is equal to y minus f, y dot is equal to minus x. And here dt can be written as dx over x dot. And what was x dot? X dot was y minus f of x. So I can change the integral in terms of x integral. And when time is moving from 0 to t1, x is moving from 0 to alpha. And then the rest of the integral will be given in terms of x as following. So y of x minus f of x. In this integral, now we want to change y naught as y naught growing to infinity. We know that this part of the graph between 0 to alpha is growing. So y of x, this is growing. This is going to infinity. And therefore, y minus f, which was positive from the graph, you can see that y minus f is positive, but it's also growing. It's only increasing. Since the denominator is increasing, the integrand will be, the absolute value will be decreasing, but, right, and the total, so counting the minus sign before, so this is positive value which keeps decreasing. So finally, the summary, the delta n is a positive number from beginning, and it's keep decreasing to 0 as y naught goes to infinity, because y minus f can be as large as you want. Let's look at delta 3, which is very similar. It's just the integral from t2 to capital T of the same form. And again, changing to x integral, then it's now instead of 0 to alpha, the starting point is t2 is alpha. It's the integral from alpha to 0 of the same integral. And this time y minus f is opposite sign because the graph of f is higher than the graph of y. But the integral also changed the order. Instead of 0 to alpha, it's alpha to 0. So it's the same phenomena. It's still going to 0, but the delta 3 is positive. So it goes to 0 as y goes to infinity. Y not goes to infinity. Finally, let's look at delta 2, which is the integral from t1 to t2. And this time I will change dt in terms of dy integral. It will be dy over y dot. And remember that y dot was minus x, so it will cancel the x before. So y dot was minus x, so it will cancel the x in the integrand. And the integral will change in terms of the y integral. Y value is some positive value at t1 and some negative value at t2. Let's write it as y of t1 to y of t2, and it's the dy integral. And here you will have f of x of t. Of course, t and y are related. Remember that value of f here is always positive. It's always positive because it's the orbit lies where the x coordinate is bigger than alpha. But the integral is from y of t1 to y of t2, which is from the positive value to negative value. So the integral will give negative value. And if you think about how the graph will change as y not increase, then as y not increase, the orbit will expand. So it will be expanding both in x direction, positive x direction, and it will also expand in positive y direction and also in the negative y direction. So the integral will only increase. So let me summarize. This delta 2 is a positive value in the beginning, and it only increases as y naught goes to a positive value. And combining these three results, delta 1 plus delta 2 plus delta 3, which was the delta, the total difference of value of w, will only going to increase both since all the values oh no, here I made a mistake at the delta. So delta 2 was the integrand is positive, but yt1 and yt2 they are, so this is positive number and this is negative number. So the integrand, the integral range is from positive to negative, so the integral will be negative, and which will increase to the negative direction. So it will actually decrease. So decrease, it's starting from negative value, and it will keep decreasing, So starting from negative value and decreases, we all proved that delta 1, delta 2, delta 3 all decreasing. And delta 1 and delta 3 is actually vanishing, starting from the positive value vanishing. Delta 2 starting from certain negative value, and it keeps decreasing, so all of them decreases to a negative value. Since we just showed that delta is monotonically decreasing to negative value, while we also showed that delta is positive when y naught is less than alpha, combining the two, there must exist exactly one point where delta is 0. Oh, so what is the delta is 0? So there is exactly one value of y naught where delta y is equal to 0, which means w of y0, w at y0 is same as w at y of p of y0. And what was w? W was just the distance from the origin, and this means exactly P of y0 will be minus y of 0. Because P of y0 cannot be y of 0, it should be the other side. P of y0 must be minus y of 0. We just found out that there exists a unique periodic orbit. Finally, we found that there's a unique periodic orbit. Now we will show that this unique periodic orbit is the stable one. So let me write down y naught to be those particular periodic orbit, the unique periodic orbit where y naught goes to minus y naught by the Poincare map. And we found this as the monotonicity of the delta. Delta was positive in the positive when it's less than y naught, and it's negative when it's y naught is bigger than this. Starting point is bigger than y naught. So this region is where the delta is positive, and this region is where delta is negative. What was the delta? Delta was the change of the value w. W was the distance from the origin, which means in the region delta is positive. If you start from some value y1, then it will, when it reaches the other point, the other point P of y1 will be farther from the origin. So which means the absolute value will be greater than y1. And similarly, if you start from, say, out in delta negative region, let's say y1 prime, then by the time it reaches the other side, it will be Poincare map of y1 prime, and that will be closer to the origin this time because delta is negative, which means the absolute value will be smaller than y1 prime. So we just show that a single Poincare map brings this 2 point y1 and y1 prime closer to this y naught by a single Poincare map. And if you follow the orbit, then the other side is by the symmetry, just applying the next period, another Poincare map. So it will just getting more close to y naught more and more. So that's the final result.